Good morning, all of you. So let's start today's class. Today, we will see arrangement of capillary tubes. Arrangement of capillary tubes. In that first one, tubes in series. What we are doing in the first case, we are connecting two capillary tubes, one after the another one. Got it? So let's see here now. I'm drawing the diagram. Let us suppose this is first capillary tube, and here is another capillary tube which is connected to this capillary tube. That is big one. Like this. Okay. So the first capillary tube is having, let us suppose, length L1 and radius of cross section R1. This capillary tube is having length L2 and radius of cross section R2. Okay. Let pressure P1 here. Here it is P0, and this side it is P2, because whatever the liquid is flowing through this is like this. Okay, right. Now, yesterday we have learned Poiseuille's equation. Yes, so we know from Poiseuille's equation, phi is equal to, V is what? Volume. Yes, no? Pi P R power 4 divided by 8 eta L. Now what I am doing, I am just keeping this P above and this pi R power 4 down. 8 eta L divided by pi R power 4. If I am assuming that this complete part is just R, okay, then V is equal to what? P by R. Now what is this R here? This R is called fluid resistance. R is called fluid resistance. Understand? Now in this case, see, R is equal to, in this case, R is equal to R1 plus R2. Okay, R is equal to R1 plus R2. Now common formula we got now here, where R is equal to what? 8 eta L divided by pi R power 4. This is fluid resistance formula. Now here R1 is there. That's why I'm substituting like this. 8 eta L1 divided by pi R1 power 4 plus, at the place of R2, 8 eta L2 divided by pi R2 power 4. Okay. And here in this Poiseuille is also, this is volume. V means volume per second, we can say. Yes, no? Volume per second. right? So therefore here volume of liquid flowing per second that is V is equal to P divided by R1 plus R2, and that is equal to P divided by this R. So whatever we got, we have to just substitute there. So P divided by R, I can take 8 eta. Yes, but what I can take common, you see? What I can take common? 8 eta by pi, can I take common? 8 eta by pi into bracket L1 by R1 power 4 plus L2 divided by R2 power 4, and that is equal to, this pi will go up, pi p divided by 8 eta into bracket L1 by R1 power 4 plus L2 by R2 power 4. Okay, this is what volume of liquid passing per unit second, or per second we can say. Even here also volume per unit second only, or per second, right? Yes, note down. Yes, finished, right? Now, what is pressure here? Because we have taken here P1, P0, and P2. So what we should substitute at the place of P? So see, here P is equal to P1 minus P2, and this P1 is equal to P1 minus P0 plus P0 minus P2. Okay, and this P1 minus P0 and P0 minus P2 is what? P1 minus P0 is pressure difference across, capillary 1 we can say, and P0 minus P2 is pressure difference across capillary 2. Now, if we will take the ratio, that is P1 minus P0 divided by P0 minus P2 is equal to R1 by R2. Yes, no, it is directly proportional, suppose. Yes, no. Then what we will get? This is equal to L1 by L2 into R2 power 4 divided by R1 power 4. So if suppose they are asking you to find pressure difference or ratio of pressure difference, then you can use this formula. Okay, so go ahead, note down this also. Yes, finished. So let's move ahead. Now, next one, that is this one finished in series, right? Now, capillary tubes in parallel. Okay, what is the next one? Capillary tubes in parallel. So let me draw the diagram first, how it is. You can see the diagram. So here it is pressure P1, here it is P2, and this is P2, length is L2, radius is R2. Here it is V1, length is L1, and radius is R1. And this is what fluid is flowing through this. Okay, like this. You see here, these two tubes are parallel to one another. And in this case, we are going to see now resistance and all. Okay. Now here, this R1 is equal to 8 eta L1 divided by pi R1 power 4. Yes, no. And then R2 is equal to 8 eta L2 divided by pi R2 power 4. Now as these two are parallel, so that's why 1 by R is equal to 1 by R1 plus 1 by R2. Same like you have learned in 10th class this formula, resistance in parallel and series. So that's why 1 by R is equal to, so pi R1 power 4 divided by 8 eta L1 plus pi R2 power 4 8 eta L2. Now what I can take common? I am taking pi 8 eta common. R1 power 4 divided by L1 plus R2 power 4 divided by L2. Okay. This is what 1 by R. Okay. And now this is 1 by R value we got. Here P is equal to P1 minus P2, and therefore volume is equal to, volume per unit second is equal to P by R1 plus P by R2. P by R1 plus P by R2. And therefore V is equal to pi P by 8 eta into R1 power 4 by L1 plus R2 power 4 by L2. Okay. Just what to do here, only I did just this P I have taken common, and this is 1 by R1 plus 1 by R2 value, which is nothing but this 1 by R, and that's why I have substituted this just with P multiplied. Yes, no? That's why you got like this. And therefore V1 by V2 is equal to R2 by R1 here, and that is equal to L2 by L1 into R1 by R2 whole power 4. Understand? So this is what the volume per unit second in parallel combination. Okay. So note down this. Okay, finished. So let's move ahead. Now one problem we will solve. See here, what is the problem? Three capillary tubes of same radius one centimeter, but of lengths 1 meter, comma 2 meter and 3 meter are fitted horizontally to the bottom of a long vessel containing a liquid at constant pressure and flowing through these tubes. What is the length of a single tube? Which can replace the three capillaries. So what is given? You see, how many capillaries we are having? Three. Yes, no? And each having radius 1 centimeter. So here, what is the case? R1 is equal to R2 is equal to R3 is equal to R, and that is equal to 1 centimeter. That is equal to 1 in 10 to the power minus 2 meter. Okay. Next lengths they have given. L1 is equal to 1 meter. L2 is equal to 2 meter. And L3 is equal to 3 meter. Here the lengths are different. Now, what is the length of a single tube which can replace the three capillaries? Means they want now single length only. Yes. So what to do? See, now first of all, this volume V is equal to, because this one tube we are making, no, so whatever the volume per second through 1, 2 and 3 tube is there, that should move through the only one tube. Yes, no? And that's why V should be equal to V1 plus V2 plus V3. Now radius we will keep same only. Okay. So see here what I'm doing. Now V1 formula is what? Pi P R power 4, because this R1 is equal to R2 is equal to R3 is equal to R, no. So pi P R power 4 by 8 eta L1. Next V2 is equal to pi P R power 4 8 eta L2, and V3 is equal to pi P R power 4 divided by 8 eta L3, and this P is equal to what? Pi P R power 4 8 eta L. Now you substitute all these things here in this equation, whatever we have, and I think now you can do it yourself. So therefore V is equal to V1 plus V2 plus V3, and that's why pi P R power 4 by 8 eta L is equal to pi P R power 4 8 eta L1 plus pi P R power 4 8 eta L2 plus pi P R power 4 8 eta L3. Now take the common, this pi P R power 4 pi P R power 4 cancel, and this 8 eta also take common and cancel. So you will get something like this: 1 by L is equal to 1 by L1 plus 1 by L2 plus 1 by L3. Now you have L1, L2, L3. You can substitute here and you can go ahead. Okay. Can you do it now? Do it yourself by taking the LCM, and don't forget to take reciprocal. Okay. Can you do it? Do it now. Yes. Okay. In the next class, we will learn surface tension. Okay. Right. So we will stop here today. Note down all this and do it yourself, whatever it is given problem. Okay. Its answer is 6 by 11 meter. Okay. Right. Bye.